Morning, everyone. So to start off with, are there any questions on the 5-4 assignment that I gave you yesterday? So one more time, any 5.4 questions? Okay, let's dig into 5.5. So I've been saying to you a number of times now that we did not have reverse chain rule. We didn't have the chain rule in reverse for integration. We didn't have a way to do that. Well, today we're going to begin to see how to do that. And you can see that it's called integration by substitution. And as you just look under these, hi Jamie, if you just look under these, I'll make this a little bit bigger. Look under that first subpoint under there. Use pattern recognition to find an indefinite integral. That's probably the thing we're going to spend the most time on during this particular session. We're also going to get to the second one. Use a change of variables to find an indefinite integral. Okay, so this is kind of our chain rule in reverse. At least we're going to start getting into it. This is more of a vision problem than anything. And by vision, I mean you got to keep your eyes peeled for certain things. And when you see them, then it'll be pretty clear how to proceed. I know that sounds general and kind of weird, but that's literally it. You got to really watch for certain things. So this just shows that we're going to be dealing with the chain rule. Okay, so let's get into an example right away. I think that's the best way for me to show this to you. So you can see in example 1, we're trying to take the integral of x squared plus 1, that quantity squared, times 2x dx. Of that expression, x squared plus 1 squared times 2x, which function is the most embedded? That is, which function is the inner part of this? And I think you'll agree it's the x squared plus 1 part. Welcome, Keenan. So this part right here is the innermost part. Okay, now if you were differentiating x squared plus 1 squared, after you've done the power rule, with the squared part, what's the innermost function is that x squared plus 1. You'd have to do the chain rule. And what would be the chain rule derivative of x squared plus 1? It's 2x. And that's exactly what we have sitting right here. Okay, so we're going to use that to our advantage. So in other words, what we have before us is an expression that the chain rule has already been used on. Okay, well then when we do the integral, it's that innermost function that we want to concentrate on, the x squared plus 1. And really, all you have to do is do that, right now, what's being done with x squared plus 1? It's being squared, right? So what do? When you do an integral? Raise the power by 1, which is down here. See how they raise the power by 1 to the cube, and then they divide it by 3. Okay, so that's nothing new. The process is not new. The problem is you need to recognize that the chain rule is already in operation with that 2x being there. Okay, so you just did your first integration by substitution, at least on the low level. And of course, we have to add a plus c on the end. Okay, so really, there's nothing new to do. The problem is recognizing that the chain rule has already been done. All right, and then capitalizing on it. By the way, if we check this, how do we check this? How do we know this is the correct integral? We would use the chain rule. And I'm sorry, we would differentiate, and we'd have to use the chain rule. So when you differentiate this, what happens? So if you take the derivative, the 3 would come down, be multiplied by 1/3 and equal 1, and you'd have x squared plus 1 squared, and then you'd use the chain rule times 2x. And that's exactly what we had in the beginning. If you look up to this very top line, it checks. That's what we've got, x squared plus 1 squared times 2x. So just keep in mind, you can always check integration by differentiating your answer. And if you come back to what was there originally, you've got it. Let's look at another example. So this time we're supposed to take the integral of 5e to the 5x power with respect to x. Well, what happens when you take the derivative? What's the innermost function here? Well, it's that 5x, right? That's kind of the inside thing. And what's the derivative of 5x? 5. Oh, and that's what's sitting right here. So just one more time. You find the innermost function. You call that, let's say, g of x. And then take the derivative of it. And if that appears elsewhere, well, you're in like Flint. I mean, you've got everything going for you then. Because then all you have, how do you take the derivative of e to the 5x? It's itself times the derivative times any chain rule, in this case times 5. Okay. So when you take the integral of e to the 5x, you're going to get e to the 5x. That 5 is there because if you check it, if you take this answer down here, e to the 5x plus c, and take the derivative, what will you get? You will get e to the 5x times 5 because of that chain rule, and that's exactly what we had up here at the top. So this is, I'm just trying to get you used to this kind of reasoning. All right. Now, to get you in the mood for this discovery of these patterns, we're going to take a look at some exploration problems here. And the first one is this integral of 2x times the quantity x squared plus 1 to the 4th with respect to x. What's the innermost function? The x squared plus 1 in the parentheses, right? And what's the derivative of x squared plus 1? 2x. Notice how this is set up really nicely. The chain rule has already been done. And so when you take when you actually execute the integral, you can go right at the x squared plus 1 to the 4th. Because this is, the 2x is there from a chain rule. What do? You raise the power by 1 up to the 5th, and you divide by 5. Add a constant. You're all done. So again, the ones we're looking at so far are set up very conveniently and very nicely for you. We're also going to take a look at problem part D. Okay, so now you notice we have a problem here. The innermost function on D is still x squared plus 1. Okay, But the chain rule tells us that you should be multiplying by 2x. And notice we don't have a 2 there. And so we can kind of make our wish come true and say, oh, I'd like that to be a 2x. Okay, let's make it a 2x. And how can I make it work out? By multiplying outside the integral by 1/2. Now, when you take 1/2 times 2x, it's back to the x it was. So now we can do the integral. We can't forget about this 1/2 on the outside. What's the integral of x squared plus 1 to the 4th? Raise the power by 1, divide by 5. Oh yeah, and don't forget that 1/2 we introduced. And then you can simplify a little bit more by multiplying the denominators 1/2 times 1/5. So here's our first one we had to manipulate a little bit. It wasn't quite a perfect chain rule, so we tweaked it a little bit so that it was, and it was a legal tweak. We multiplied by 2, and we right away multiplied by 1/2. So it was a fancy way of multiplying by 1. Okay, I want to look at a couple more examples, and we're going to look, that's down on this slide. All right, so this time we're going to take a look at part B. Okay, part B is, you notice we have this x cubed plus 1 is that thing underneath the square root sign. That's our innermost function, okay? And what's the chain rule of that inner part? 3x squared. Oh, that's perfect. You see how we have a 3x squared sitting there? Okay, so we're all set up. And what's another way to write x squared plus 1 under a square root? It's x plus 1. So that's written like this. X squared plus 1 to the 1/2 power. All right, so this is just set up as perfect. I mean, the 3x squared is just there as part of the chain rule. All right, now when we integrate, what is x cubed plus 1 to the 1/2? Raise the power by 1. So raise 2 halves. That brings it up to 3 halves. Divide by 3 halves, which is the same as multiplying by 2/3. And at a constant, integral is done. If we integrated this, if we differentiated this, we'd come right back to what we had in the problem, and therefore it checks. Okay, now we're going to look at E, which has this it has a need for a tweak again. Okay, so in E, again, x cubed plus 1 is the innermost function, and when the chain rule is used on that, you get 3x squared. Oh, but that's not quite right because we only have x squared. So here again, let's tweak it. Let's make it 3, like you see I did in this last row here. Let's make it 3, and let's multiply by 1/3. Okay, now it's set up perfectly. The chain rule is now illustrated. Now we can differentiate. We can't forget about that 1/3. Take the x cubed plus 1 to the 1/2, raise the power by 1. So we're up to the 3 halves again. Divide by 3 halves, which is the same as multiplying by 2/3. 1/3 times 2/3, the 3's cancel. You get a 2 on top and you get a 9 on the bottom. At a constant, voila, we have the integral. So let me just pause here. Does anybody, since none of you is rude enough to interrupt me, which I very much appreciate, but I'd sure like it if you guys would ask questions. So I'm just going to give pause here for a minute. Do you see what's happening here? Do you have any questions at all about what I'm doing so far? All right, I'm going to move on. Thank you for the feedback. So this idea of finding the pattern, and once you find the pattern, there's nothing new. You just integrate in the normal way. Once you realize, oh, the chain rule was used here, then you can do your normal integral. At the bottom it says, you know, some integrants are almost correct except for the coefficient. That would be a perfect example of what we did in part E. So this originally read, remember, x squared times the square root of x cubed plus 1. And x squared is not quite the right chain rule. It should be a 3x squared. And this says, okay, you can go ahead and tweak that by putting in a constant and pulling, you know, and then multiplying by the inverse, so it comes right back to where it was. Here's another, here's an example of that. Let's just take one more look at a problem. So here we have the integral of x times x squared plus 1 quantity squared with respect to x. The innermost function, I think, is quite obvious. It's the x squared plus 1. And if we use the chain rule on that, what would we be multiplying by? 2x, right? And, oh, that's almost correct. We've got an x out there. So what are we missing? Yeah, we're missing a 2. And so when you put a 2 in there, you can equalize things, you know, by pulling out a, you know, by multiplying by 1/2, right? So I know they didn't quite show it the way I'm explaining it. So when you take your integral, you've got you know, the chain rule says this should be a 2x. So if we make it a 2x, we can do that, and it's still correct. 1/2 times 2x is going to be the original x. So now we know we've got that set to go. And then, all right, go at the x squared plus 1, the one that was there. This is just part of the chain rule. And you execute. Raise the power by 1 to the 3, which they did down here. Raise the power by 1 and divide by 3. And then we can't forget about the 1/2. You combine that. Okay, so this is an example of that constant tweaking that you can do to get the chain rule to be just right so that you can then reverse it. All right. So this is just a friendly reminder that what I just did is perfectly legal, but don't ever do it with a variable. Let me explain. So remember, what did I pull out? I pulled out a constant, 1/2, and I put a constant in, 2. If you are, let's say you need an x squared and you don't have an x, can you multiply by an x and then put a 1 over x out here? No, you cannot do that with a variable. So what this is saying is you can only pull, let me just underline, applies only to constants. So, okay, just a very important point that needs to be made. Okay, so now we graduate to something might be a little more difficult for you to grasp. Okay, so here's an example of what's the innermost function here. I'm sorry, if you take the integral of the square root of 2x minus 1 with respect to x, the innermost function is obviously 2x minus 1, right? What's the chain rule when it's applied? Yeah, we'd need a 2. And I suppose we could do it the other way, but we need to learn this way. Okay, so what you can do is take the innermost function. Whoops, let me just make that a little bit smaller again. You can take the innermost function and set that equal to u. This makes it a little bit easier. U equals 2x plus 1. Well, then, if you said, all right, 2x minus 1. If that's u, then du dx, let me change, I'm sorry. I'm trying to do too much at once here. So that's u. Now, if you take the derivative of both sides, du with respect to x, that's 2. And if you solve for du, you get this form. And it's also important to go back and solve for dx, or just do it from right here. If you solve for dx, you would divide both sides by 2. dx equals du over 2. All right, those are substitutions that we're going to need. All right, so now let's take the original problem and let's rewrite it with u's. That's what I'm doing right there. The square root of 2x minus 1, that's the square root of u. All right, and dx, we're going to substitute what we had up here in the top right corner, du over 2. So this is just a rewriting of the problem in terms of u. All right, now let's differentiate. So this 1/2 comes from here. They brought that out and they just said, let's move the 1/2 off to the side. Now, how do you integrate u to the 1/2 du? You raise the power by 1 and you divide by that new 3/2. That's the same as, all right. And then add a constant. So when you pull that out, when you divide by 3/2, it's the same as multiplying by 2/3. The 2's cancel and you get 1/3. So there's my integral. But now you don't want the integral in terms of u, so now you substitute backwards. What do you plug in for u? You plug in that original value of 2x minus 1. Integral complete. This is called the change of variables, and this is probably the one thing that's going to take a little while to get used to. I'll leave that up there for a few seconds. Some of you may be taking notes. Jordan's having trouble, I can see. Sorry about that. All right. So let's try another one. I guess, yeah, this one's slightly different. Okay. So, once again, I'm going to set u equal to this inner part. This inner part, what's the innermost function up there? It's 2x minus 1. Okay, so we set that equal to u. And then, do a little algebra. We need to solve for x. Why? Because we're going to have to make a substitution up there when we change this into a u problem. So, we add 1 to both sides and divide by 2. You get the value for x. Okay, so now if u equals, I mean, we don't have to do this over again, but u equals 2x minus 1. The derivative of u with respect to x is 2. And so derivative of u equals 2 dx. And what? Dx equals du over 2. So now we're ready to go. We want to translate this expression into u's. So the square root of, in place of x right there, we plugged in what we just found right here, u plus 1 over 2. And then the square root of 2x minus 1. Okay. Yeah. The square root of 2x minus 1 is the square root of u. which they wrote as u to the 1/2. And then in place of the dx, you plug in du over 2. So this is the new problem after translating to u's. We can take out both these 2's, as denominators, and let's stick them over here. So we stuck a 1/4 to the left. All right, what's left is u plus 1 times u to the 1/2. So, what they did is they did this multiplication. And when you do that, u to the 1/2 times u to the 1 is u to the 3/2. And then u to the 1/2 times 1 is u to the 1/2. So there's our problem, all in u's. So now integrate with u's. So raise the power by 1. So 3/2 goes up to 5/2. Divide by 5/2. Second term, raise the power by 1. U to the 1/2 becomes u to the 3/2. Divide by 3/2. Plus c. Okay. Now, we got to do a couple things. If you're dividing by 5/2, that's the same as multiplying by 2/5. And 2/5 times 1 over 4 is 2/20 or 1/10. And in place of u to the 5/2, now plug in the original 2x minus 1. And then in the second term, 2/3 times 1/4 is 2/3 times 1/4 is 1/6. And then plug in u, what u is equal to, and add a constant. We're done with the derivative. So this substitution, this is change of variables. It's going to take a little while for you to adjust to this. That's, by the way, I didn't say it, but this is going to be a 2-day lesson. I'm going to give you the assignment, but we're going to give you till Friday to get this done. Okay? So you're going to need a little bit more adjustment time. Let's do another change of variables problem. Okay. Yeah, now we have this little algebra issue. The integral is the sine squared of 3x times the cosine of 3x with respect to x. All right. So this really means right? Isn't that what sine squared of something means? It means take the sine of that 3x and square it. Okay. The reason I wrote it that way is it helps you see better what's the innermost function. What's the inside thing going on here? It's the sine of 3x. That's what they're trying to tell you right here. Okay, so that's what we're going to have be our u. That inside function, u, is the sine of 3x. And then if you do du, you take the derivative of that, you're going to get the cosine of 3x. Oh, and then there's a chain rule. They got to multiply by 3. So here's what du is. We can divide both sides by 3 and come up with this. Okay. So now let's substitute. Let's change this into a u problem. What's the sine squared of 3x? Remember, u is the sine of 3x, so this must be u squared. And what's the cosine of 3x dx? It's du over 3. Okay, now we have a u problem. Let's pull that 1/3 out to the left, and it looks like this. Now integrate using your reverse power rule. Raise the power on u by 1, u cubed, divide by 3. So there it is, 1/9. Actually, 1/9 u cubed plus c. But what's u? Oh, it's sine of 3x. We're done. Now, here they took the time. Let's check this. Let's see if this really works. We should be able to take the derivative of this answer, and we should be able to come back to the original problem, which was up there. Sine squared 3x. So if you take the derivative of 1/9 sine cubed 3x, the first thing you got to do is the power rule, right? You got to take that exponent of 3, bring it out in front, multiply it, reduce the power on the sine of 3x down to squared. Then you got to do the chain rule. What's the sine of 3x? The derivative of that is the cosine of 3x. Oh, and then you got to do the chain rule again because 3x, yeah, has a 3 in it. Well, look what happens when you simplify this. 3/9 is 1. I mean, if you multiply by these two 3's, you get 9. 1/9 times 9, 1. Sine, so we get the sine squared of 3x times the cosine of 3x. That's exactly what we began with up here on the top. So that assures us we know we did it correctly. I don't know. Hopefully you're picking this up. But all right, I'm going to give you an extra day to get used to it. So let me show you what the task is, and then we'll see if you have some things we want to go over. The assignment for Friday is 4 sections of odds. 5.5, 1 to 29 odd, 33 to 41 odd, 43 to 53 odd, and 69 to 83 odds. The beginning ones are going to be real reachable for you. You should be able to wipe out that first you should be able to get into the first and the second sections pretty easily. Then that change of variables will kick in and you'll have a little more trouble. So the assignment, this is the assignment for Friday. Okay, but I want you to get started on it. We will not start a new lesson tomorrow. We will rehash this lesson, and I want to maybe show you a little bit more detail. Maybe we'll do some more examples. So yes, you will be able to work on this during class tomorrow. Thank you for the questions. Now, I want to show you just a couple problems. We're not done yet. So part of the assignment is to get you into this labeling thing and to get you used to this. So when you look at, for example, number 1 here, and you've got the integral of 8x squared plus 1 quantity squared times 16x dx, can you see what the innermost function is? It's the 8x squared plus 1, right? Well, that's that's what you will be. Okay, and then what's the derivative of that? What's the derivative? What if you execute the chain rule? The derivative of 8x squared plus 1 is 16x. And then you look over here and you go, oh boy, this is set up perfectly. That one's, it's got a chain rule sitting right there for you. How about number 2? What's the innermost function? Pretty clear. It's x cubed plus 1. What's du? What's the derivative of x cubed plus 1? 3x squared. Is this one set up perfectly? Not quite. You see what we're missing here? We're missing a 3. By the way, you are not supposed to go ahead and do the integral. You're just, in this section, all you're doing is finding these 2 boxes, Get the idea there? But if we were going to integrate, we would be short of 3 here. So we would do this kind of thing and then continue integrating. But, you don't have to, all you got to do is fill in these two boxes. How about number 3? Well, I mean, let's see. What's the derivative of the tangent? Secant squared. So I don't know if you can tell, but that inner function here has to be the tangent of x. And then what's the derivative of that? The derivative of the tangent is the secant squared. So, I mean, if you were going to integrate this, you would now have, you know, here's your u, and this is your du. So what you have here is u squared du. And now you can integrate, then you can come back. Anyway, you don't have to do that, but I'm just getting you into that mode. So let's just practice one of these, and then I'll let you go off. How about we take number 6 here? Okay, it says find the indefinite integral and check the result by differentiation. Okay, so number 6. Well, what's the innermost function? That's the x squared minus 9. That thing inside the parentheses the most. What's du? The derivative of that is 2x. Oh, that's set up nicely, isn't it? So what's our integral now in terms of u? It's u to the third du. Right? du is 2x. So, by the way, that's supposed to be dx here. So, all right. So now what's the integral of u cubed? Raise the power by 1 and divide by that. Okay. But, so the answer is u to the 4th, 1/4 u to the 4th. But in terms of u, now just plug your original back in, 1/4 x squared minus 9 is your u, and that's the 4th power. So we're just getting used to this. Let's see where you take it in one day. We will spend a second day on this tomorrow. Does anybody have questions to ask? Probably a ton of them, which is fine. Let them fly. It's going to take a little while for us to adjust to this. Okay, then we're going to call it quits. Thank you. I will see you tomorrow.